The next few types of questions will be very similar to what we did in Chapter 8. For a collected sample, we can find the confidence interval, and also we can do inferences based on the sample. We're going to first look at a confidence interval for a normal population mean with a small sample size. We had a formula similar to this before. How do we find a confidence interval? We have had x bar minus z half of alpha times s divided by square root of n, and x bar plus z half of alpha times s divided by square root of n. So you can see that the only difference is we just change the z half of alpha to t half of alpha, and when we have a small sample size, so which means it's a t distribution. So we can look at example. Suppose we have the weights of 8 female wolves in the Ucayali Rivers National Reserve. Suppose we have 57, 84, 90, 71, 77, 68, 73, and 71. Because it's difficult to catch wolves, and also these wolves might be dying, and we may not be able to get a large sample size. So these are the weights of these 8 wolves, and so we want to first of all, as you can see, the sample size is small, and so we're going to question A. We want to find 90% a 90% confidence interval for the population mean. And notice the difference between population mean and sample mean. Population mean, that means all the wolves, this kind of wolves we have, we have to catch all the wolves and add all the weights together, divide by the number of wolves we have. But again, it's impossible to catch all the wolves. We only have a sample of 8. So what we're going to get is going to be called a sample mean. We take the sample and we add all these numbers together, and so I'm just going to write down, after we add all of these values, we're going to get 591 divided by the sample size 8. So we're going to get 73.875 pounds. But notice we are interested in population mean. So the average weight of these 8 female wolves is 73.875 pounds. But does it mean the average weight of all the wolves, female wolves, also is equal to 73.875? So this is what we call mu. The symbol we use is mu for population mean, but this is what we got. What we actually can get is called a sample mean, x bar. So here is the what we need to tell people how good our sample mean is compared to the population mean, how close this is to the population mean. Or what we actually want to construct is a population mean. So what would be the range for the population mean? We know that population mean most likely is not going to be exactly the same, but if we can give a range based on sample size, based on the sample mean, and that can give us an idea about the population mean, which is the average weight of all the wolves. So by using the formulas, we write down this formula here. The formula is x bar minus t half of alpha. Because it's small sample size, we cannot use z, we use t value, times s divided by square root n. That's the lower bound. Upper bound would be adding t half of alpha times s divided by square root n. So this is the interval we're going to get. As you can see, we already have x bar, so we can plug into the formula 73.875. So we can plug this number for these two. But with s, we're still missing S, where S is the standard deviation. We learned how to calculate this before, and to save time, I'm just gonna give you the answer. So variance, sample variance is gonna be 101,208. So we learned this in chapter 2, and take square root, so we can get around 10.063. So sample mean and the sample standard deviation can be found based on the samples. And the we found a value for S. Sample size n is given 8. So the only thing missing is the t-value, which we have discussed how to find the t-value. So 10% confidence interval. Again, I'm going to draw a sketch graph to help us understand how to find this t-value. This is the bell-shaped curve, and so we want to find we want to find a 90% confidence interval, which means an interval we're going to find starting from somewhere and lower bound and end with somewhere. So this is the interval we're looking for, such that the probability or the area under the curve is equal to 90%. So we want to be 90% confident. 90%, we can convert this to decimal, that's 0.90. We want to know 90% chance the population mean is between this value and that value. Okay, so let's find the t-value here. And notice that this is the area in the middle. We won't be able to use this t-table directly. We have to find the right side area. And to do that, we did an example previously, exactly the same thing. I guess we can bring that up, or we can just redo this here because we have a different sample size. Previously, the example we did is with the degrees of freedom 17, but because the sample size is 8, the degrees of freedom will be 8 minus 1. That's going to be 7. Because notice that the sample size will affect the value. And so we're going to look at found this value right here first, right side area. So we do 1 minus 0.90 divided by 2. That gives us 0.05. This area to the right, let me highlight this area. It's going to be 0.05. So now I can use the table. Degrees of freedom is 7. The area is 0.05. 0.05. Degrees of freedom is 7. So we can find the value is 1.895. We found this value, which is our t half of alpha, 1.895. And we don't really need the negative value here, so we're going to plug this number into the formula. That gives us x bar, it's 73.875 minus t half of alpha, which is 1.895 times S is 10.063 divided by the square root of 8. That's the lower bound. The upper bound is 73.875 plus 1.895. That's this value here is t half of alpha times S, 10.063 divided by the square root of 8. You can see these two lower bound and upper bound, they're very similar, except one of them is minus, the other is plus. Because this is our error margin, and so we add this to sample mean to get upper bound and subtract it from the sample mean so we can get a lower bound. So after we simplify this using calculators, we will get the answer that is equal to 67.13, 80.62. So this tells us a range for the population mean. So let's look at this one more time. 73.875. That's the average weight of these 8, only these 8 wolves. So for all the wolves we have, the average weight of all the wolves is going to be a value between 67 pounds and 80 pounds. So between 67.13 pounds and 80.62 pounds. So it's somewhere in these two values. And the second part of the question is, although we did say mu is going to be between here, but again, we are only 90% confident. We're not 100% sure the population mean is going to be between there. So the second part of the question, part B, is asking, is population mean included in this interval? I mean, all you can say is not for sure, because again, we only have 90% chance that mu is between these. It's possible that mu is going to be greater than 80.62. Maybe it's like 81 or 82, or it could be below. It could be like 65 or even like 63 or 50. So it does not guarantee 100% the population mean is going to fall on this interval, but it just gives a high percentage that mu is going to be between these two on this will fall in this range. As you can see from this example, to find the confidence interval for small sample size, the formula is very similar to the confidence interval for large sample size. The only difference is, instead of using the normal standard distribution table, we have to use t-table to find this t value instead of the z value.